we were doing some special series, and let us see question number 3 of exercise 9.4. Find the sum to n terms. Series is 3 into 1 square plus 5 into 2 square plus 7 into 3 square plus dash dash. So we separate the sequence. The first term is written 3, 5, 7 dash dash, and the second term 1 square, 2 square, 3 square, and dash dash. Now we find the nth term of these two series. So nth term of 3, 5, and 7. This is a plus n minus 1, 3 plus n minus 1 into 2, and 1 squared, 2 squared, 3 squared. It is not in AP or not in GP. But when we remove the square, we get the sequence in AP 1, 2, and 3. So we remove the square and find the nth term. So a plus n minus 1, and common difference is 1. And then we put the whole square because there was a square on each term. So first we remove the square and it remains 1, 2, 3. Then we find the nth term and then put the square. So 3 plus 2n minus 2, 1 plus n minus 1, the whole square. 1 and 1 cancel, and here we get 2n plus 1 into n square. Now we remove the bracket, so 2n cube plus n square. Then for finding Sn, we can write summation n equals to 1 to n and 2n cube plus n square. Then we separate the terms. Sn equals to 2 would be taken outside. Then summation n equals to 1 to n cube plus summation n equals to 1 to n and n square. So Sn equals to 2 as it is, and the value of sigma summation n cube n into n plus 1 by 2, the whole square, plus sigma n square. Its value is n into n plus 1 into 2n plus 1 upon 6. So to remove the bracket, n square n plus 1 the whole square upon 4, 2 the square 4, and n plus 1, 2n plus 1 upon 6. Then we take common from both the terms. N into n plus 1 upon 2 is the common. Here we get n into n plus 1 plus 2n plus 1 upon 6. So n into n plus 1 upon 2, and take LCM inside the bracket. So 6n into n, 6n square plus 6n plus 2n and plus 1. So n into n plus 1 upon 2, 6n square plus 8n plus 1 upon 6. Six n square plus 6n plus 2n plus 1 So 6n square plus 8n plus 1. Here comes 3. We have taken upon 2 as common. So LCM will be 3 and 3n square plus 3n plus 2n plus 1. 3n square plus 3n plus 2n, 5n and plus 1. So n into n plus 1 upon, here also comes 3. 3 into 2, 6 and 3n square plus 5n plus 1. So this is the sum to n terms. Next, question number 4. One upon 1 into 2. 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4 plus dash dash. Then we find the nth term. So an of 1 upon the denominator is separated 1, 2, 3, 1, 2, 3, dash dash and 2, 3, 4, 2, 3, 4. So nth term an equals to 1 upon nth term of 1, 2 and 3. A plus n minus 1 into d. Common difference is 1. And nth term of 2, 3, 4. A plus n minus 1 into d. So we get 1 upon 1 plus n minus 1 and 2 plus n minus 1. So 1 and 1 cancel and n plus 1. It becomes 1 upon n into n plus 1. This is the nth term of the sequence. Now we will write, let 1 upon n into n plus 1 equals to a upon n plus b upon n plus 1. We separate these two terms as a sum or difference. So the LCM would be taken n into n plus 1. We get an plus a. From here we get bn. And on the left side there was 1 upon n into n plus 1. So denominator gets cancelled and 1 equals to, from these two terms, n is taken common. A plus b into n plus a. Now we equate the coefficients from both sides. So the coefficient of n on the right side is a plus b. And the coefficient of n on the left side is 0. The constant term is 1. A equals to 1. If a equals to 1, Then put the value of A equals to 1, we get the value of B equals to minus of 1. Then we put the value of A and B in first number equation. So from first, 1 upon n into n plus 1 is written as A upon n, means 1 upon n, and the value of B is minus 1. So minus 1 upon n plus 1. So this is the nth term. An equals to 1 upon n minus 1 upon n plus 1. Then put the value of n equals to 1, 2, 3, dash, dash up to n. When we put n equals to 1, we get a1 equals to 1 by 1 minus 1 upon 2. For n equals to 2, 1 upon 2 minus 1 upon 2. For n equals to 3, we get 1 by 3 minus 1 by 4. Dash, dash, and for n equals to n, we get 1 upon n minus 1 upon n plus 1. Then column wise we add. When we add all these terms, a1 plus a1, a2, a3, an, we get a7. 1 by 2 cancelled, 1 by 3 cancelled, 1 by 4, 1 by n will get cancelled, and it remains 1 minus 1 upon n plus 1. So Sn equals to 1 minus 1 upon n plus 1. We take LCM. So n plus 1 minus 1 upon n plus 1, 1 gets cancelled, and the result comes to be Sn equals to n upon n plus 1. Next question number 5. Five square plus 6 square plus 7 square plus up to 10 square. 5 square plus 6 square plus 7 square plus up to 20 square plus dash dash up to 20 square. So the given series is not in AP, or also it is not in GP, but it is started from 5 the square, and the formula which we have, it is from first 10 terms, or first 20 terms. So what we will do? Add 1 square, add 1 square plus 2 square plus 3 square plus 4 square. Add and subtract. Add and subtract. Add and subtract. So we add 1 square plus 2 square plus 3 square plus 4 square. 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square plus dash dash plus 20 square. Then we subtract minus 1 square plus 2 square plus 3 square plus 4 square. We add these 4 terms, 1 square plus 2 square plus 3 square plus 4 square, and the same terms we subtracted. Now there are total 20 terms, and the formula for Sn is 1 square plus 2 square plus 3 square plus dash dash n square. The formula was n into n plus 1 into 2n plus 1 upon 6 minus, there are 4 terms. So the formula n into n plus 1 into 2n plus 1 upon 6. In this case, the total number of terms is 20. So we put the value of n equals to 20. So 20 into 20 plus 1, 21. 20 into 2, 40 plus 1, 41 upon 6 minus. There are 4 terms. So at the place of n we put 4. 4 into 5 into 9 upon 6. 2 3 ja, 2 3 ja, or 3 2 ja. 3 2 ja 6 and 10 2 ja 20. 3 7 ja 21. Here 2 3 ja 6, 3 3 ja 9 and 2 2 ja 4. So we get 10 into 7, 70 into 41 minus 5 into 2, 10, 10 into 3, 30 and 70 into 41, 2870 minus 30. We get 2840. The result comes to be 2840. Question number 6. Three into 8 plus 6 into 11. 3 into 8 plus 6 into 11 plus 9 into 14. 9 into 14 plus dash dash. So we separate the terms and we find an of 369. 369 dash dash and also nth term of 8 11 14. 8 11 14 and dash dash. So we find the nth term a plus n minus 1. 3 plus n minus 1. At the place of d, there is 3. And this is also term of AP. So a plus n minus 1 into d. Common difference is 3. So 3 plus 3n minus 3 and 8 plus 3n minus 3. So 3 and 3 cancelled, we get 3n and 3n, 8 minus 3 plus 5 and 9n square plus 15n. This is the value of an. Now for finding Sn, we use the formula sigma n equals to 1 to n. An and the value of an is n equals to 1 to n and 9n square plus 15n. 9n square plus 15n. Then Sn equals to 9 is taken outside. Sigma n equals to 1 to n, n square plus 15. Sigma n equals to 1 to n and n. Then Sn equals to 9 and the formula for sigma n square. This is n into n plus 1 into 2n plus 1 upon 6 plus 15, and sigma n is n into n plus 1 by 2. This is 2 3 ja 16, 3 3 ja 9. Now we take common. So 3n and n plus 1 upon 2 is common from both the terms. 3n into n plus 1 by 2 is common. So 3n n plus 1 by 2 we have taken common, so there comes 2n plus 1, and here it gives 5. So 3n into n plus 1 into 2n plus 6 upon 2. From these two terms, we take 2 as common. So 3n into n plus 1, and taking 2 as common, n plus 3 upon 2. 2 and 2 cancelled, and the result comes to be 3n into n plus 1 and n plus 3. 3n into n plus 1 and n plus 3. Question number 7. This is 1 square. 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square. Plus dash dash dash. So the nth term is an equals to 1 square. This is 1 square, 1 square plus 2 square, 1 square plus 2 square plus 3 square. Next series will be 1 square plus 2 square plus 3 square plus 4 square, and the last will be 1 square plus 2 square plus 3 square plus dash dash n square. So we remove the square. We remove the square and we find the it's the value of 1 square plus 2 square plus 3 square plus n square. Already we know the formula. N into n plus 1 into 2n plus 1 upon 6. The formula for sigma n square means 1 square plus 2 square plus 3 square plus dash dash n square, and its formula is, its sum is n into n plus 1 into 2n plus 1 upon 6. So an equals to 1 by 6. Remove the bracket by multiplying them. So 2n square plus n plus 2n and plus 1. Then 1 by 6, 2n square into n, 2n cube, 2n plus n, 3n into n, 3n square, and n into 1, n. So an equals to 2n cube plus 3n square plus n upon 6. And when we find Sn, so Sn equals to sigma n equals to 1 to n, and 2n cube plus 3n square plus n upon 6. Then we separate the terms. Sn equals to 2 by 6 means 1 by 3 sigma n cube. N equals to 1 to n. This is 3 by 6 means 1 by 2 sigma n square, and n equals to 1 to n, plus 1 by 6 and sigma n equals to 1 to n sigma n. Now we write the formulas. So Sn equals to 1 by 3 and sigma n cube. The formula for sigma n cube, n into n plus 1 by 2 the whole square plus 1 by 2, and the formula for sigma n square, n into n plus 1 into 2n plus 1 upon 6, then 1 by 6 and sigma n. Sigma n is written as n into n plus 1 upon 2. So it comes 1 by 3 into n square, n plus 1 the whole square and 2 the whole square, 4, plus 1 by 2 into 6, 1 by 12, n into n plus 1 into 2n plus 1, plus 1 by 12 and n into n plus 1. This is also 3 4 ja 12. Now we take the common from the entire terms. So the common is 1 by 12 and n into n plus 1 is common. So here we get n into n plus 1 plus 2n plus 1 and plus 1. So n into n plus 1 upon 12. This comes n square plus n plus 2n and plus 2. Then n into n plus 1 upon 12 and n square plus 3n plus 2. N square plus 3n plus 2. So the result is n into n plus 1 into n square plus 3n plus 2 upon 12. Yes, correct. N into n plus 1 the whole square. N plus 1, 2n plus 1 upon 6, sigma n plus 1 by 2, 1 by 6, n plus 1 by 2n plus 1, n 1 by 6, n 2n square plus n plus 2n plus 1, so 2n cube plus 3n square plus n, 2n cube plus 3n square plus n by 6, 1 by 3 sigma n cube, 1 by 2 sigma n square, 1 by 6 sigma n. So 1 by 3 n square, n plus 1 the whole square, 4, 1 by 12 n plus 1, 2n plus 1, n plus 1, 1 by 12 common n plus 1, so n into n plus 1 plus 2n plus 1 and plus 1, n square plus n plus 2n plus 2, 3n plus 2. And this can be expanded, so n plus 1. This can be written as n square plus 2n plus n plus 2 upon 12. So n into n plus 1. From these two terms, n is common. So n plus 2 plus 1 is common, n plus 2 upon 12. So n into n plus 1. Here n plus 2 is common into n plus 1 upon 12. So n into n plus 1 the whole square into n plus 2 upon 12.